Welcome to MatheNatic. In this video, we'll revise the 3 rules of differentiation. For the first rule of differentiation, we have fx is equals to k, which is a coefficient, times x to the power of n. And if I find the derivative of fx, we have f prime x, and we say that we take k times n, which is the exponent of x, times x, and then we subtract 1 from the exponent. So let me show you how that looks like. Let us say we have fx is equal to 7x to the power of 4. Now if I apply this rule and I want to find the derivative of that term, then I'll say this is 7 times 4, which is 28, x to the power of 3. So what I'm doing is I'm taking the exponent and I'm multiplying the coefficient with the exponent. That's where the 28 comes from, so that's kn. And then I subtract 1 from the exponent, as you can see in our rule. So 4 minus 1 would become 3. So that's our first rule of differentiation. The second rule says that if we have fx as k, which again is the coefficient, times x, then the derivative would be simply the value of k. Let me show you an example again. Let us say fx is equal to 6x, then the first derivative of fx would simply be 6, which is the coefficient. So in this rule, our exponent is already 1, but it is actually an application of the first rule. Let me show you. If I have fx as k times x, that's the same as saying x to the power of 1. Now, if I apply the first rule, which we have learned, then we'll have f prime x as k times 1 times x, and we subtract 1 from the exponent. So I'm simply applying this first rule. I'm multiplying the coefficient with 1, which is the exponent, and I subtract 1 from the exponent. And when I simplify that, that's the same as saying k, because k times 1 is k, x to the power of 0. And hopefully by now you know that anything to the power of 0 is simply 1. So this is k times 1, and that is k. But as you can see, by using the first rule, it becomes quite long, so it is much easier to simply remember that if our exponent is 1, then the derivative of fx simply becomes the coefficient. Let's move on to our third rule, which says that if fx is equal to a constant value, then the derivative of fx is 0. So let's say, for example, that fx is equal to 5, then the derivative of fx is 0. And this again is an application of the first law. So let me show you what I mean. If fx is simply 5, that's the same as saying 5 times x to the power of 0. And if I apply the first law, or first rule of differentiation, this becomes 5 times 0 times x to the power of 0 minus 1. Now 5 times 0 becomes 0, and then this will also become 0 by multiplying by x, so this is simply 0. But again, we want to avoid any tedious calculations or manipulations in calculus. So what we rather do is we try to remember the 3 rules. The first rule is the one that you would use most often. So that is when we take the exponent and multiply the coefficient with that exponent, and then subtract 1 from the exponent. And you can also do it mentally as we did in our first example. I hope you enjoyed this video. Please subscribe to this channel for more videos like this.